Okay. So we're the Waupaca Foundry casting cleaning team. We are a multidisciplinary project working on a way to clean metal castings for Waupaca Foundry. We are made up of electrical engineering majors, computer engineering major, robotics engineering, and 3 mechanical engineering technology majors. So we've got a lot of ground to cover. We're working on a way to figure out how to decore castings. You can see in the bottom of the screen there is a finished casting, a 3D model along with the core right next to it. The cores are what is put inside the model, as you can see in this video, with these pink bars to make the passages inside of the casting. And once the casting has been cooled and finished into a metal part, it can't be sold until all that core sand has been taken out of the casting. Our main goals for this is to figure out a way to decore the casting, inspect it after it's been cleaned, and then automate the processes as well. Our sponsors don't currently have a way to do any of this by hand, so it's a big undertaking for all 7 of us.
To test this method of core sand removal, we are using the Omler MBL RVC70 decoring hammer. Prior research and testing shows this to be a safe and reliable way to decore castings. On the right, there is a custom tripod mount for the Omler hammer with the respective casting clamps.
The decoring hammer seen on the last slide is powered by a pneumatic system. This system was developed with our team along with Donald Engineering to provide the system with dry, filtered, and lubricated air. The system also has a poppet valve, which is a safety for the hammer so that if it gets jammed, it cannot damage itself.
In addition to decoring, our team developed a novel design of an IR inspection probe to be inserted into the casting. Top left on the slide is a cross-section of the 15C casting showing a IR LED and a phototransistor. IR light is shot from one side of the passage and detected on the other end, and the degradation of the intensity of light correlates to the blockages in the passageway. Bottom left shows the 3D printed probe with the IR and phototransistor that we are using as a sensor. Non-visible light was chosen due to its use in factory automation and the ability to test while visible light is present. To do this, we utilize an Arduino with embedded code to take multiple readings while also sweeping the sensitivity of the sensor during testing. In addition, our team was able to detect the reduction of blockages after being decored with the Omler hammer.
Omler also makes a system which integrates several hammers along with a soundproofing cabinet which includes sand reclamation. Should the sponsor go forward with the process, we are recommending buying this.
Based on our research, we showed concept potential for the implementation of our decoring and inspection processes.